In this video, we are going to see an overview of the interaction of particles with objects and the simulation system. So, as usual, let's create a basic emitter. And what I want these particles to do is bounce off a very complex and intricate object, a sphere. So let's make a sphere, and let's rewind, press play, and extend the timeline to 600 frames. And you can see that the particles are going through the sphere because we haven't told the particles to do anything else. In order to make particles react to objects in the scene, we are going to use one of these modifiers, the collide, the pyroadvect, the stick, and the surface attract. And each one does a different thing. The simplest one is the collide. So let's add a collide modifier, and nothing happens. Maybe I need to rewind. Nothing happens. That's because in order for an object to be recognized to run in the particle simulation, it has to be designated as a simulation object. So the sphere, all that it requires is for you to go and add from the simulation tags a collider tag. If I rewind now and press play, you will see that the particles now are going to react to the sphere and they're going to bounce off it. This is as simple as it gets. From this point onwards, you can start playing around with the various parameters of the collide modifier. And it gives you a general idea what it's doing. So we are telling it to collide upon intersection. This intersection is based on various parameters and substeps and stuff like that, but it generally works. We can also make them collide and bounce off with a radius. We can control, and I like to increase the number of particles here and take my sphere and put it closer because I'm too lazy to wait for too long for the particles to reach the sphere, and now we can see things quite closer. And you can see there's this buffer. They're colliding at a certain distance, which happens to be, if you go to the collide, around 10 centimeters. If I increase that, you will see that they're going to bounce further back. And you can use a combination of both the intersection and the radius. And we can control the amount of bounce and so forth. So let me set this back to intersection, and let's move back a bit. And I'm going to show you one of the most interesting things that the interaction with simulation object has, and that's the target group. So that upon this collision, we can tell the particles to change group. And that's fantastic because then we can tell them to do something else. Let me show you what I mean. Particle group, let's call this collided. And I'm going to tell my collide only to apply to the particle group, so that once they collide with this object, then they are going to ignore this object. But in the collided, which I'm going to drag in here, I'm going to set the collided to be red, so just so that we can see them in the viewport using a different color. I'm going to set both of these to have a radius of 2. And let's see what this is going to do. There you go. They just bounce off and they go into a different group. But this group is going to have some gravity. So let's go here, add some gravity, make it less, and rewind and press play. Now you can see the gravity is applying to all the particles, and that's because I didn't make it a child of the collided group. So now I'm only applying this gravity to the collided group. So once they collide, they're going to start falling. Now the only problem with this is that any particles that collide up here are going to go through the sphere. In this particular case, if I want the collision with the simulation objects to apply to all the particles, all I have to do is pull it out. And that's another example of how you can use a hierarchy to tell one or more groups to do something. So there you go. And now these are going to bounce again and fall down and so forth. And this is how objects interact with the particles, and you can do all these nice things. We also have repel, kill. So now the particles are going to die, and because they're dying, they're not going into the other group. But this is sort of a contradiction of our setup. It's not a mistake or anything like that. It's a purposeful mistake to show you something. Now, let me talk about the stick for a second, although it's not that much different. The stick allows you, let me get rid of the collide, to stick the particles on collision, or change strength, or do all sorts of other things. And one thing you need to remember about the stick, it has the unstick parameter, so that you can move them to a group or something like that, then in the other group have an unstick or have another parameter that controls something else. In this particular case, I'm just going to make sure that they go into the collided and rewind, press play, and you can see that they stick. Fantastic. Now, because they're stuck over here, well, gravity cannot take place because these are stuck. Now, when you have these sort of conflicting forces, you can always go and say, well, I want the stick to have a lesser value. So now you will see that we get a bit of movement here. The particles are trying to do something. There you go. So they're sort of sticking, but they're sort of pulled down with gravity and so forth. There are ways to make them hit the sphere and then start dripping down and so forth. I'm just showing you this little overview so you know what's going on. Now, let's get rid of all this setup and create a new scene, because I want to show you one of the most interesting of all the modifiers, and this is the pyro advect. Now, in order to do that, I'm going to create a very simple pyro simulation. And stick with me, because what you're going to see is going to be quite impressive. I'm going to create a small sphere, 30 centimeters, because it's my favorite sphere size. I'm going to put it here. I'm going to create another one and put it over here. I'm going to select them both and go and add pyro tags. Let's go down here and add pyro emitters. So there you go. And they're going upwards as we would expect. Now I'm going to take this pyro emitter over here, and I'm going to go to the velocity. Let me close everything I don't need to see. And in the velocity, I want to make sure that it's not set to movement, but it's an absolute velocity, and it's emitting towards this direction. I want these to go quite fast, and I want this to emit in the -1z, and it's going to go backwards. So let's see that happening. There you go. So I'm having this smoke that is pushing this way. I'm going to do something equivalent for the other one. So I'm going to go to set absolute velocity, 1,000, and I'm going to set this not upwards, but in the positive z direction. And we should have these two pyros that are sort of meeting in the middle. Fantastic. Now let me bring these a bit closer. Let's bring this a bit closer, because I want these two pyro simulations to kiss. I could put some music, but I don't know about the usage rights. But in any case, there you go. We have this fantastic thing. So far, so good. The pyro output is generating density, temperature, and velocity. And let's see now how we can make this pyro simulation react with particles. I'm going to call this right and this left. And I'm going to select this and introduce a new emitter. That's the mesh emitter. And it's just going to use that mesh, the geometry, to emit some particles. But in any case, we're going to talk about this later. Select the right one and create a mesh emitter. So we have these two particle groups. I'm going to make sure that these two emitters, because it's a mesh, I can emit from the volume or the surface or anything I want. I'm going to emit a shot, and I'm going to emit 10,000 particles for each of the emitters. Rewind, press play, and you can see that they just fly away. If we want the particles to interact with the simulation, we just need to go and add a pyro advect. And the default state is good enough for our particles to move. That's all we need to do. It reads all the simulation data, and that comes from the pyro. And look at that. The particles now are moving in that direction. So let me do something. I'm going to go and make this invisible. Now it's still drawn because I need to go to my project settings, simulation, pyro, and go all the way down to the end where it says draw and not draw it anymore. So now we're only going to see the particles. And I'm going to make the spheres invisible as well. Fantastic. So if this is not impressive enough, watch what I'm going to do now. The computer I'm using now is a run-of-the-mill Dell workstation, an amazing machine. It's quite old, and it has an RTX 5000 card, which is similar to the 20 series, and it has 16 gigs of RAM. Why am I saying this to you? Because watch what I'm going to do next. I'm going to select my two mesh emitters, and I'm going to shoot from each one 5 million particles. We are going to see how our simulation and 10 million particles, approximately 5 from each emitter, work when I play real-time using my Pyro Advect. This is real-time playback, and it's 10 million particles. And if you're wondering how we can see the particle count, all you have to do, I don't know if I showed you in another video, select the particle group and go to points mode. And here we have 5 million particles, and here we have 5 million particles. So we have 10 million particles in total. And I hope you agree with me that that's not too shabby. Talking about performance, so this would be the maximum performance you would expect from the system, and it's actually spectacular. But we need to have some performance considerations in mind, which we are going to address in the next video, so stick with me for a moment.